Hi everyone. So today we are going to start with the chemical reaction and equation chapters. So this is the first chapter of class 10th and it is very important not just for your 10th class but also for your 11th and 12th class because this is having some basic, some key idea about what chemical reactions actually are. Okay, so we will be starting with this chapter now. So let's get started. So as the name is suggesting us that we will be talking about the reactions. Okay, so it's a very important and interesting chapter also. So what is chemical reaction? This is first what we are going to study, what a chemical equation is. Okay, so let's quickly start with the chapter from the beginning itself so that you all can understand what all the lines in the NCERT book is saying. So now see, consider the following situations of daily life and think what happens when you know that when we keep the milk in the room at the room temperature during the summertime, it gets curdled, right? So the milk will convert to curd because of the bacterial growth in it, right? And if we keep an iron tawa or a pan or a nail and it is left exposed to the humid air, that is again going to do oxidation of the iron pan, right? Grapes get fermented if they are kept in the open environment for a very long time. Not in an open environment, grapes otherwise also get fermented. Even if you're keeping them in a fridge, it will take a longer time, but still it will get fermented. Now, cooking of food is again a chemical reaction, right? Now, digestion of food in our stomach is also a chemical reaction that is taking place. We respire, the taking in of oxygen, the formation of the combination of glucose with that oxygen in our blood. So that is also a chemical reaction that is taking place in our body. So whatever we have studied in all these examples, these are telling us that some chemical process is taking place, right? So whatever names I've taken or whatever things I've told you all as of now, all these are chemical processes. They all are chemical process, right? So in the above situation, the nature and the identity of the initial substance have changed somewhat, right? So if we talk about when the reactant is not the same as a product, we can call it as a chemical reaction, right? Or a chemical process has taken place. So we have already learned about the physical and the chemical changes of matter in our previous chapters. So physical change means when something is let's say smell is changing, melting point, boiling point, all these things are the physical things, solid, liquid, gas, the change of state, right? But if we talk about chemical changes means when the reactant was something different, but the product form now is something different. Okay, so that is a chemical reaction. So whenever a chemical reaction changes occur, we can say that a chemical reaction has taken place, right? So now you may perhaps be wondering to what is actually meant by a chemical reaction. Like I just told you all that whatever things I've told you, the curdling of milk, the digestion of food, whatever I'm telling you, if I am not writing that either in the form of an equation, okay, so that will be a chemical process. So when I'm saying the milk got curdled, that means I'm telling you that some chemical process has taken place, right? But if I'm writing that in the form of an equation, then I'm saying that this is the chemical reaction that is taking place. So how do we come to know that a chemical reaction has taken place? Now, how will you, this is like a first question, that how will you get to know that yes, a chemical reaction has actually taken place? So for this, I have two tricks, whatever suits to you people, you can learn it. It is SGT, CSGT, and the another trick is GST. You all know that GST is a charge which is charged by the government to us, right? So GST and C just include, you have to include, okay? So GST, C. G stands for evolution of gas. That means whenever a chemical reaction is taking place and some gas has evolved, if some gas is evolved, from that we'll quickly get to know that yes, a chemical reaction has taken place, okay? Because this is something which is changing, right? Or the state of the substance which was in the reactant side and now on the product side, it is changing. So that is also going to tell us about that yes, a chemical reaction has taken place. And temperature change. Let's say earlier the reactant was there and the temperature was, let's say, cool. But later on, when the product was formed, its temperature increased. That means temperature change is also going to tell us about that yes, a chemical reaction has taken place. Okay. And C stands for the change in the concentration. Okay, change in the color. Like if I'm saying concentration, concentration means I'm talking in terms of color. Let's say you're having a red color here, let's say, okay, but on the product side it is changing to orange or maybe to yellow. So because the color is changing, the color change is also telling us that yes, a chemical reaction has taken place. Okay, so the answer to this question, that how do we get to know that a chemical reaction has taken place? So this is the question. So the answer to this question will be either evolution of gas. Either evolution of gas can tell us that yes, a reaction has taken place. Okay, the trick was GSTC, right? Evolution of gas and change of state, right? Change in temperature. Temperature can be either exo or endo. What is exo and endo? That also I will tell you all. And then color change. So if the concentration of the color on the reactant side and the product side is changing, that is also telling us that yes, a chemical reaction has changed. Okay. And if I add one more thing to this, order change is also there. Okay. So if the order is also changing, that means the smell is also changing, then that is also indicating us that yes, some kind of chemical reaction has taken place. Okay. I hope that's clear to everyone. And now we'll look to one activity, and by this you will understand that how a chemical reaction is taking place. Now, if you see this, you will see there is a magnesium ribbon that we are taking and we are burning it. Okay. So we are holding that with the tongs. We are holding this magnesium ribbon with the tong. Okay. And then we are burning it. So before burning, we have properly rubbed this magnesium ribbon with the sandpaper so that whatever magnesium oxide layer was there on the top of that magnesium that can be removed, and then we will burn it. And then we are having one white colored solid product that we have found in the watch glass, that is of magnesium oxide. That means when we are burning magnesium, the symbol for magnesium is Mg. So when we're burning magnesium in presence of oxygen, this is a symbol for burning. Triangle is a symbol for burning. So when we are doing this, the product that we're getting is magnesium oxide, which is white in color, Okay. So this is it. So what we have observed here, now see, I'll read this so that you all can understand what all we have done here. So we have taken a clean magnesium ribbon of about 2 centimeters long by rubbing it through the sandpaper. We have cleaned the outer magnesium oxide layer and then we are burning it. Now hold it with a pair of tongs, burn it using a spirit lamp. Okay, this is a spirit lamp, you can say, or it's a burner. Okay, you can either use a spirit lamp or you can use the burner. Either of them you can use. Okay, then and collected the ash so formed in a watch glass as shown. Now burn the magnesium ribbon, keeping it as far as possible from your eyes so that you are properly safe while you're doing this experiment. So what we have observed here, that a chemical reaction has taken place when the burning of magnesium ribbon was done, right? Now you must have observed that magnesium ribbon burned with a dazzling white flame. Always remember, whenever magnesium will burn in oxygen, it will burn with a dazzling white flame and changes into a white powder. You know that the color of magnesium oxide is white, as I've already told you. This powder is a magnesium oxide. It is formed due to the reaction between magnesium and oxygen in presence of the air. Now you all can see this reaction is not balanced. Now why am I saying that this reaction is not balanced? Let's see this. We're having one magnesium and one magnesium. Good. That means magnesium is balanced. But if you see oxygen, oxygen is 2. and oxygen is 1. That means it's not balanced. We need to add one more oxygen to this. So for this, I can put a 2 here. Now, oxygen is good. Oxygen is properly balanced. But now the problem is with magnesium. Now, magnesium is not balanced. That means again, now we need to put a 2 here. Finally, now our equation is balanced. Okay. So this is a balanced equation. Now, what I've done is a balanced chemical equation. One more thing, if I tell you, if I remove this 2 and this 2, then this equation will be called as a skeletal equation, which is an unbalanced equation. Unbalanced equation or skeletal equation. It is only a skeletal present in, like you can learn it in this way. I generally tell my students in the school also in the same way, that you can learn it in this way. As in our body, if we don't have the organs, we don't have the skin, we will not look that good. We will look very thin and very slim, right? So our skin is adding beauty, our fat is adding beauty to us, right? So that means skeletal is a basic thing which is required in our body, right? So that skeletal is this equation, but it is beautified with the addition of the numbers on the both the sides, on the reactant and the product side, to balance the reactant side and the product side. Okay, so this is a balanced chemical equation if I add 2 and 2, as I've already told you all. And if you're not balancing this equation, it is a skeletal equation, which is also called as an unbalanced equation. I hope that's clear to all of you. And now we will be taking some more examples. Now, let's talk about activity 1.2. Take lead nitrate. You should be aware of all the symbols. Like lead is Pb, nitrate is NO3. Okay, and because the valency of lead is 2. Okay, some of you find problem with this also, so I will explain it. Now see, Pb is having a charge of +2. NO3 is having a charge of -1. Just cross multiply and you will get your answer. Because NO3 is a polyatomic ion, that's why I am using the bracket around them and then I'm putting a 2. So if it is 1, you don't need to mention it as 1 specially. So you can properly write it like this. So this is the formula of lead nitrate. So what they are telling us to do is that take lead nitrate solution in a test tube, that you have to take a lead nitrate solution in a test tube, and in a after addition of this, add few we are now adding to this potassium iodide solution. What is potassium? K, and iodide is iodine. This is the iodide, right? Now see, K is also +1, potassium is having a valency of +1, and iodide is also having a valency of 1. Okay, and while writing the formulas, we are not concerned about the charges. So that's why K will be 1 and I will also be 1. So we don't need to mention 1, as I've already told you, right? So this will be it. Now, when you will put an arrow, because it's a chemical reaction, so you will get the product as PbI2 plus KNO3. But now this equation is not balanced again. That means this is a skeletal equation. But if I will put maybe 2 or maybe 3, whatever number you require to just balance the things on the reactant side and on the product side, that will be a balanced equation. Let's let me put, okay, I'll use some different color. PbNO3, Pb is 1, Pb is 1. That means good, we are balanced. NO3 is 1, is 2 on this side, but on the product side it is 1. That means it's not balanced. K is 1, K is 1, balanced. I is 1, it's 2. I think if I put a 2 here, and if I put a 2 here, now this equation is balanced. 2K and 2K here. 2 potassium this side, 2 potassium this side. 2 iodine, good. NO3 is 2, NO3 is 2. Pb is 1, good. This is balanced. So now this is a balanced chemical equation. This is a balanced chemical equation now. Okay, so this is how we balance the equation. Now one more very important thing is that what is the color of this PbI2 form? The color of the PbI2 form is yellow. So this can directly come in your paper. You know, when you will do this reaction, the color will suddenly change to yellow. So when you will add this potassium nitrate solution, and to that you will add the potassium iodide solution, the color will suddenly change to yellow. And that yellow color is because of the formation of lead iodide. Okay, so this is the yellow colored precipitate that will be formed. Okay, so precipitate is formed, right? So that is also showing us that yes, a chemical reaction has taken place, as you have already written in that question which I've told you, the change in color. So because there is also change in color, this is telling us that yes, a chemical reaction has taken place. Okay, so what we have observed here, that the change in color is there because of PbI2 form, and that is yellow. Okay, I hope that's clear to everyone. Now, from the above, okay, one more activity is there. I think I should first discuss this. Now, one other activity is take a few zinc granules. Zinc granules is Zn. The symbol for zinc metal is Zn. Granule means you're taking some pieces of zinc in a conical flask. So this is a conical flask, okay? And to this you're putting zinc granules or a test tube, and you're adding some HCl with the help of the another beaker you're adding, or the test tube. You can put HCl, and to that we're now adding the zinc granules. Okay, it's not compulsory that you have to use HCl only. You can also use H2SO4. Okay, so we are using this. So what is going to happen here is, it's a simple thing. You just need to learn one thing and you will get your answer. Just give me a second, I'll write it. Whenever you're having a metal and metal is placed in any acid, it is always going to give H2. Some exceptions will be there. We will be discussing some examples also. So whenever you will put the metal in any acid, hydrogen gas will be evolved and a salt will be formed of metal. Okay, so that means hydrogen gas is one thing which is surely going to happen there. So that means on this also, when you put the zinc granules here and some HCl is there, acid is there, or maybe dilute sulfuric acid also you can take. So evolution of hydrogen gas will be there. So I will give a question related to this also, maybe in the upcoming videos, because this is what is directly given there in your NCERT book. But how a question can come in your board exam related to this particular topic, that I will upload in the coming videos. Okay, maybe I will take one video of completely important question which I think can come in the board exams. Okay, so we have seen that the evolution of hydrogen gas is taking place here, right? So we have seen here that hydrogen gas is showing us, because it is an evolution of gas is showing us that yes, a chemical reaction has taken place. So I think that's clear to all of you. So as we observe the changes around us, we can see that there is a large variety of chemical reaction taking place around us. We will study about the various type of chemical reaction and their symbolic representations in this chapter. Okay, so if we talk about the chemical equation, chemical equation is, I've told you what a chemical process is, what a chemical reaction is when you're writing the reactor and the product with the arrow, that is a chemical reaction that you're representing in the form of an equation when you are writing their symbols. Okay, now see, if you're writing complete magnesium, then you're writing the complete word for oxygen, for complete word again. So whenever you write the equation in this way, I always tell the student to learn it in this way, that you're writing the complete names, magnesium, oxygen. So that means you're using the words to write it. So that is what a word equation is. Okay, so this is a word equation. I hope that's clear. So in the activity 1.1, we can be described as when a magnesium ribbon is burned in oxygen, it gets converted to magnesium oxide, as you already seen. This description of a chemical reaction is sentence form is quite long. If I'm saying magnesium is burned in presence of oxygen, so that's a very big line that I'm telling, right? So it can be written in a short form. The simplest way to write down this is in the form of word equation. So I've written in the form of word equation, right? So I've told you all what a word equation is. Now, the substance that undergo chemical change in the reaction, let's say magnesium and oxygen are the reactant, right? The new substances, that is magnesium oxide, during this is the product. During this reaction will be the product. That means this side is the reactant side and this is the product side, right? So word equation shows changes of reactant to product through an arrow. So this is what a word equation is telling us, right? So the reactant are written and then a plus sign is indicated if two reactants are there, right? Similarly, products are written on the right hand side with a plus sign between them. The upward arrow point toward the on the direction of the product side. Okay, so this is what a chemical reaction is. Now, how to write a chemical equation? As I've already told you, when you're writing the equation you're writing the chemical reaction in the form of magnesium reacted with the oxygen in presence of heat. So this is a chemical reaction that you're writing, right? But if you write the symbols of them, that will be the chemical equation. So is there any other short way for representing the chemical equation? Chemical equations can be made more concise and useful if we write the chemical formula instead of the word. Don't write the complete words, write the formulas, right? So chemical equation represent a chemical reaction by their symbols. So let's say for magnesium, we've written Mg, for oxygen O2, and this is the product that we're getting, right? Then we need to count the atoms present on the reactant side. We need to count the reactant present on this side, atom present on the reactant side, and the atom present on the product side. Because we have to make sure that a reaction is properly balanced, because you know that there's a law in chemistry which says that energy can neither be created nor destroyed. That means mass can also not be created or destroyed. If a chemical reaction is taking place, if we are having one magnesium this side, there, or then on the product side also, it should be one magnesium. The complete equation should be balanced. This is a universal law. It should be balanced, right? And not just the atoms. The atoms also should be balanced on both the sides. Their masses should also be balanced on both the sides. And the charges on the reactant side and the product side should also be balanced. Only then we say that yes, a chemical reaction is totally balanced, right? Now count and compare the number of atom on each element on the LHS and on the right hand side of the arrow. Is the number of atom of each element same on both the sides? If it will be same, then it is a balanced chemical equation. And if the reactant thing present on the reactant side and on the product side, the things are not equal, so that is not a balanced equation. That means it is not following the universal law which I have just told you, right? So this equation is called as a skeletal equation until unless it is not balanced. If it will be balanced, it is a balanced chemical equation. So I hope everything till here is clear to everyone. I've told you all what a balanced chemical equation is. That also we've already discussed. So now we'll directly talk about this reaction. See, this is the word equation. Zinc plus sulfuric acid is giving us zinc sulfate and hydrogen. So this is the word equation. So now we will be writing the formulas for them. Like for zinc, it is Zn. For sulfuric acid, it is H2SO4. So when they are reacting, I've told you when you're having a metal along with the acid, the product form will be just straight away write H2. One thing will be H2. Now write whatever is left. So this is a metal salt, right? So hydrogen gas is formed. So see, evolution of hydrogen gas is there, right? So then you just have to balance it because it is not balanced. So just see if things on the reactant side or the product side is balanced or not. Let's see for this equation if it is balanced or not. One zinc balanced, H2 balanced, SO4 balanced. So that means this is already a balanced chemical equation. You don't need to balance it. It's already balanced, right? Okay, so this is another equation. So now let us try to balance the following chemical equation. Now this is a chemical reaction in which iron, Fe is for iron. When iron is getting reacted with water, when Fe is coming in contact with the water, so it is going to give us Fe3O4 with the evolution of hydrogen gas again. If you remember, again it is a metal, right? So when metal come in contact with water, it is going to form Fe3O4, okay? And this is the hydrogen gas. So now let's try to balance this equation. So first we will be writing, so this is our equation we have written in the form of brackets. Now see how many Fe are there, how many Fe are there. That means not balanced, you need to put a 3 here. Now see your H atoms and your oxygen atoms, and you will be able to do it. Just try to do it by yourself, because I have already taken 2 examples. So this you can do by yourself. And still, if you find any kind of doubt in this, you can comment down in the comment box. I will make sure that in the next class I tell you this concept. Okay, so you will be easily able to do it. Okay, now one last thing for today is that writing symbols for physical state. Physical state means either if it is solid, liquid, gas, what? Okay, so for that, for solid we represented by S, for liquid we represent by N, for gas we represented by G. Okay, and when it is aqueous solution with water, we write it as Ag. Okay, so this is the notation, as I've already told you all this. So yeah, this is it for today. In the next class, we are going to talk about more reactions and their balancing, and then I will be moving ahead with this topic. Until then, this is it for today. Now we will be meeting with some new topics of this chapter. Till then, take care. Bye-bye, all of you.